if the electron is made of localized light, then it will be pretty surprising if the proton wasn't also made of localized light. The question is, how does that work? And the answer we came up with a long time ago is that the electron's a complete turn. It goes back and bites its own tail in a single motion. But imagine there are things which do some twisty stuff, but end up just doing this. A result of the motion is that it kind of misses, and you have something which ends up being a 90-degree turn. Now that's not a particle, of course. It's something came in and came out again, but it's not a complete system. But if you've got such objects, if such objects exist, you can make them into complete structures by, for example, doing exactly the reverse of this, the mirror image of it, and that should give you a particle. So you should be able to go leftwards and then go the opposite way rightwards and come back to where you started with, some which is just the same, one's left, the other's right. So if such objects exist, you can fit them together in Lego by taking another one here and then doing exactly the mirror image of that and coming back. If you imagine that just being in a mirror, that would work. But there's another way to do this. So if I've got something which goes, so that's one way of fitting two things together seamlessly, so you make a single flow, a single object. The only other way to do it is to, if you want to do things with the same handedness, not with an opposite handedness, but with the same handedness. If you go from, for example, X to Y, then if you try and go from Y to Z, you can't make it fit. You can't make the whole thing fit. But if you have three of them, if you go X, Y, Y, Z, Z, X, then you can put them together in such a way that the flow is a complete three-dimensional path. So if such objects exist, they should have two choices for forming other particles. You should be able to take one of these things and take its anti-thing and put them together and make a particle. Or you should be able to take three of the same kind of things and then bolt them together to make a full three-dimensional flow. In other words, there should exist objects for which three of them make a particle and for which a thing and its anti-thing make a particle. So, if you go to the standard model, what do you observe? You have these things called quarks, and they come in exactly that variety. You have two kinds of particles, either three quarks, or a quark, and they're called hadrons, things like the proton and the neutron, or you have things that are called mesons, which are quark and antiquark, and that's all you have. And this model explains those as well. So it explains some of the starting parts, not all of it, because remember, the model's still in development, but it's beginning to put in place some of the starting points of the next level, the standard model, the rest of the standard model. So it's starting to look at some aspects of that as well. A theory should generate new routes for experiment, for testing it, finding out, disproving it if necessary, if it's wrong. And there are a lot of tests of this new model that need to be carried out. One of them is, the conjecture is, there exists a thing called pivot, called this root mass term. Such stuff has not been observed on Earth in the lab. We don't know. Nobody's isolated pivot, nobody's seen it, nobody knows what it is. It's only a part of this crazy theory so far. The question is, does it exist or not? Can we make it? Can you isolate it? And so one experimental test is to attempt to isolate this stuff in the lab and then measure it. And I'll come back to that in just a second, because I think that this stuff might be the long sought dark matter as well. So, but you need to generate this stuff. The problem with pivot is that it's an integral part of matter. Any local matter close to pivot will just absorb it and integrate it as energy into the system. Just mop it up. So a reason that we might not have seen it is that if we do experiments in labs made of material, which we tend to do, then the lab will absorb pivot very, very rapidly, and you'll never see it because it's already there. And in fact, if we take this teapot here in the theory, a quarter of that teapot would then be dark matter. A quarter would be the counterpart dual dark matter, a quarter would be electric, and a quarter would be magnetic field. But you'd never see it separately from the teapot, because the dark matter is there hiding in plain sight in this teapot. That's a quarter of a teapot worth of mass. So to generate it, you'd need to try doing something like cancelling fields in a vacuum, and then probing the area so there was no chance for the pivot to be reabsorbed by matter, and then probing the area to see if it did anything, if it bent light, for example. If you can't, it's quite possible that that's not possible anyway. In the same way that you can't make light without charge, you might not be able to generate free pivot. If so, a route for testing this would be to look at spin polarized scattering, because when you spin polarize an electron, what you do is, instead of the thing going round itself and being spherical, you pin it perpendicular to its spin, and then you should be able to see that three-dimensional structure, that toroidal structure, begin to emerge. So spin polarized scattering should give you anomalous scattering at moderate energies, not at high energies. Another test could be that the existence of fat photons, photons with angular momentum greater than h bar, means that electromagnetism is continuous. In the fractional quantum Hall regime, it's quite possible that photons will be emitted with different quantization, with lower quantization. Now, they couldn't be emitted because they couldn't be absorbed by any local material. So an experimental test of whether this happened or not would be to take fractional quantum Hall material, have it emit radio wave photons, have a potential absorber which you take in and out of the fractional quantum Hall regime. Out of the fractional quantum Hall regime, no emission. Into the fractional quantum Hall regime, emission would switch on. So you'd be able to switch on emission from remotely by changing something in the environment. That might be an interesting test. I haven't talked about neutral angular momentum change. This comes from the other equations, which I didn't go into. But one thing is that dark matter is that pivot may already have been observed. Because the thing about pivot in space, free pivot in space, is it will be transparent to photons. It would interact only gravitationally. It could be as thin as you like, because it's not, if it was free, it would just be like a free fluid. It wouldn't interact with itself, it wouldn't hit itself, except for gravitationally. Pivot out there in intergalactic space would be a source of dark matter. It's cold dark matter, it's not moving quickly, so it's a candidate for dark matter. And if that were the case, one would expect to see experimental signatures of the interaction of pivot with matter, and those would be things like gamma ray flashes. If you hit a big lump of pivot, it might be the power source for quasars. They're a set of things you would expect to see. You might have pivot giving solar coronal heating, for example, if pivot's being generated by magnetic field cancellation outside the sun. Then you'd have a bunch of this pivot stuff sitting around, which will be absorbed by any plasma or matter that came through, heating it enormously. And, well, we know that the solar corona is immensely hotter than the surface of the sun. How does that happen? Well, this could be a reason. This could be an explanation for that mystery as well. So there's a bunch of experimental tests. Many more can be imagined. This is just a small number. So the conclusion is that a new linear theory of light and matter explains a lot of mysteries. There's a better description for light, for the photon. The quantum bicycle motion self-confines mass and charge and describes the inner working of particles that look very like the electron and the positron, and other elementary particles too. And also the new theory may explain a bunch of mysteries that are extant in astrophysical and astronomical cosmological experiments, such as, for example, dark matter. That's a quick exposition of the Quantum Bicycle project as it stands in 2018 at the moment. Thank you very much.